Hi, everybody, and welcome to Summer Genetics. I'm Dr. Guy Barbato, and I am looking forward to this semester and this summer session. Summer sessions are always a lot more fun than the regular semester, in part because we get to integrate lab and lecture a little bit more tightly than if you had a separate professor, one for lecture and one for lab. So we'll get to do some fun things I think, and a little bit different than perhaps you've done in the past. As you know by now, this is a completely online course. While we will mostly be asynchronous, we are meaning not in the same place at the same time. We will try to, I'll try to arrange starting in the second week of class right after July 4th weekend, try to arrange some time where we can get together in Zoom meetings, and I'll hold several so that if certain people can't make it to one, they can certainly go ahead and make it to the other. So to start things off, let's take a peek at our way to get in touch with me. We will be using Blackboard throughout the entire course, so please try to get in touch with me using Blackboard. It is the best and quickest way. However, I am always available by email. You can find me a lot easier to remember GFB and the number 1, GFB1 at stockton.edu. And also, if you notice right over here, if you notice the at GFB1, which is my Twitter handle, and you can find me there as well. Our blog, which we'll be talking about in a little bit more detail in a bit, is actually located here as well. Take a peek. It's at http or https www.punnettsquare.com. Those of you probably remember what a Punnett square is, and we get 2 T's and 2 S's, so sometimes it's a little tricky to spell. And that gives you a sense of where to find me. A pretty fair question that I get asked a lot is, where in the world are you from and how'd you get here? I've been at Stockton nearly 10 years. In fact, this is my 10th year here. But before I got here, I have this little Google map. You can kind of see where I'm from and where I've been. I was born and raised in the early days in scenic Newark, New Jersey. My folks left Newark. Both of them were teachers at Union High School in Union. Go Farmers. Anybody ever think of Union as a farm? Well, not anymore, probably. I loved science, loved biology, and as a result, I did what kind of probably most of you who love science and love biology and are interested in the way living things function. My mother immediately decided that I should be a doctor. And in fact, a real doctor, as she continued to say. In fact, even as I was teaching at a couple med schools along the way, she would say, could you take a few classes and finally become a real doctor? Needless to say, it didn't work out that way. I spent some time in Wilkes-Barre, Pennsylvania. I went to what is now known as Wilkes University. Back then it was Wilkes College. Got my BS in biology. And then I drove the long haul down Route 81 down to Blacksburg, Virginia, and became a Hokie. I got my master's degree in nutrition and my PhD in genetics. I was one of the first people to be involved in the idea of nutritional genetics and was involved in the study of the genetics of growth, development, and obesity, using both birds and mice and rats as a model. Along the way, I received a job when I graduated at Holly Farms Incorporated, which is down there in the little even further northwest, as if that were possible. We used to joke that Wilkesboro, North Carolina, which is where Holly Farms was was not the end of the world, but you could see it from there, and you really could. I enjoyed, in retrospect, I enjoyed my time there. Mostly, I was looking forward to getting back to the university. I was pretty lucky. I was able to get a postdoc looking at genes that influence obesity at the College of Medicine at Columbia University. I then shot, after a couple of years there, I shot across the river. I realized that I did not know enough chemistry and shot over and did a postdoc in protein chemistry at Rutgers, Newark. I was half-time in the Department of Chemistry and half-time at the Institute of Animal Behavior there. And in 1987, early in 1987, there was an advertisement in Science Magazine, which we'll get a chance to talk about a little bit later on in the course. There was an advertisement in the back for a professor at Penn State and looking for somebody who knew something about nutrition, physiology, but was primarily a geneticist, had worked with chickens before, but would be willing to branch out into other animal species. And of course, I raised my hand. I said, pick me, I can do it. And I fooled them, and I could do it. And so I was at Penn State from 1987 to 2009. I had a phenomenal time at Penn State. I would say a moderately successful career. I spent time working with universities at the University of Cairo, in Neuilly in France, also at Wageningen University in the Netherlands, and I started consulting for both the agricultural and pharmaceutical industries as well, applying genetic techniques to different projects with them. Along the way, I had an opportunity to start my own biotech company. I've got about a dozen patents, and those patents had to do with genes involved in reproduction, and so invertebrates. And I started a company called Galamed Sciences, took early retirement from Penn State, moved to New Jersey, and in fact moved to scenic Long Beach Island. So I kind of left Happy Valley for magic Long Beach Island. And had a biotech company for a number of years. Closed the company in 2014 and had a number of friends at the universities around here, and so I was able to pick up some teaching. Started at Ocean County College, Stockton, did a little bit at Kane University as well, and I'm still at Stockton teaching genetics. So I have a little bit different kind of background than a lot of your other professors, perhaps, in the sense that I have a lot of academic experience. I was actually head of the graduate program in genetics at Penn State for 7 years. I have over 60 referee journal publications, chapters in books, etc. But at the same time, as I mentioned, have patent experience in intellectual property and have been involved in the business world for quite some time, both with my consulting and also beginning my own company. So a lot of different experiences, and we'll get to talk about some of them throughout the next few weeks. Mostly, I want you to take a look at the syllabus, which is located on Blackboard. You should have gotten my email to talk a little bit about the syllabus. Please read it. It is a little bit on the long side, but again, many of the pages have to do with policies and procedures that are used at the university, as well as resources that you can use to help yourself during your time here at Stockton. And especially since we're online, some of the resources aren't easily available, or certainly not as easily available as if you were on campus. The grading policy here is pretty easy, and just let me briefly touch on how it works. There are a total of 720 total points in the course. Remember that the laboratory accounts for 25% of your total grade. So the laboratory accounts for 170 out of those 720 total points. Again, a little bit different. You will get a grade for laboratory. However, that grade does not contribute to your overall grade point average. Your grade point average will be determined by your 4 credits in genetics, and the laboratory grade gets folded into your total grade. Notice that we have 2 exams, each one worth 100 points. They will come at the end of weeks 2 and weeks 4 during the summer session, and of course a final exam, which is worth 150 points. In general, exam 1 consists mostly of genetics problems. Exam 2 is a little bit more multiple choice, fill in the blank, and deals with the biochemistry of the gene. And the final exam at 150 points is indeed cumulative and will be a combination of problem sets, answers, and applications of genetics to individual clinical issues. There's another 100 points, that is the value of an exam with our class blog. If you did not get an email invitation to participate in the class blog, please let me know and I'll make sure you get one. People are registering at different times, and so I sent out the email the other day. So if you did it afterwards, there'll be 100 points. And of course, the problem sets or assignments that we'll have done are worth another 100 points. We will have weekly assignments throughout the semester. They are no longer really group grades or group problems. I don't quite know how we would do groups in a completely asynchronous online format. If anybody has suggestions, I'm certainly open to it. You are welcome to work together on it, so if you want to share some information back and forth, but generally the grades and the assignments will be submitted individually, and they're worth another 100 points. So those will be due the first 5 weeks of class, so basically that's 20 points a week in assignments. To make life easy, I'm showing you the grades around here, and the grades basically are anything greater than 662 total points, you get an A, 590 and above, you get a B, anything 518 and above, get it? Seahorse, seahorse. And of course, if you have less than 517 points, basically that is you're a dead fish. And the reason I say that is that anything less than a C will not transfer for those of you who are going to try to transfer these credits. And certainly at Stockton, less than a C in genetics will not count toward graduation and your ability to progress in a biology degree. So it's really important that you keep up with all the work, keep up with the readings, and just complete the assignments. It's really not that difficult. And in fact, this reminds me to tell you, read the syllabus. Don't worry about Piazza. We're not going to do that this semester. Make your readings, take notes, review your notes, keep up with your blog postings, and of course, keep up with your assignments. There's really, in red here, this is the important thing. It takes me about 3 to 4 hours to prepare a lecture. You've got to be spending the same amount of time reading the book, studying your notes, doing the problems. It's really not that hard. You just have to keep up. That's really what it boils down to. It's even more important because we're online. Online implies that the responsibility is for you to keep up. I can't be in class urging you on or trying to provide some enthusiasm. I'm always available on Zoom, certainly. You can certainly email me, contact me via Twitter, but any of those things, and I'll do the best I can. But remember, online puts the burden on you. I always get questions, what's on the test? And the bottom line is, here was the answer to that question from my old analytical chemistry professor, Dr. Owen Fout. Owen used to say, the exam will be derived from everything from the first day to what we covered today and any other discussions that may have occurred during lectures. So the bottom line is, everything is available on the tests. So you just got to be prepared. I really revolve the idea of the course around two basic concepts. And the first of those concepts was verbalized by Theodosius Dobzhansky, one of the great evolutionary geneticists in our recent history. And he said a little quote that ends up in the front of nearly every biology text that's available. And the quote says, "Nothing in biology makes sense except in the light of evolution." I think about evolution and talk about what evolution means. And it's in its simplest, most deconstructed sense. Evolution is not, did you come from monkeys? Do we all share common ancestry? Evolution means from generation to generation, genes change. And in particular, gene frequencies change. Gene frequencies change because genes influence the ability of organisms to leave offspring. And as Charles Darwin first pointed out, the one who leaves the most offspring, or the most copy of their genes, wins. So I like to deconstruct Dobzhansky's quote a little bit further and emphasize that nothing in biology makes sense except in the light of genetics. So I think that's a really important way to approach the course. The second thing that has really influenced me over the years is the changes in human population growth. And I really became interested in this in the mid to late 90s when I was working at the University of Cairo. I spent 3 months in Cairo and in Egypt, traveling around teaching genetics. And it really came to the forefront of my mind how important population growth was to our well-being as a species. And you can kind of see the frightening expansion of population. It was not that long ago, the 1800s, where there were only 1 billion people in the world. Some of you, I'm sure, remember 2011 when we passed 7 billion. We are going to pass 8 billion in 2024, and estimates are in 2040. So that's only 20 years from now. There are going to be 9 billion people in the world. I'm going to go out on a limb here. Actually, it's not much of a limb. People always ask, how can you be so sure? And the answer, if we take a look at this graph, by the way, all these slides are available in the lecture slide content area in Blackboard, sorted by week. And if you take a peek at the UN population projections from now till 2100, now, of course, we can't take 2100. A lot can happen between 2040 and 2100. But for 2040, I don't think 9 billion is a stretch. And the main reason I say that, pandemic aside, is that all of the parents of the people who will be born over the next 20 years are already alive. So even assuming just simple replacement, meaning 2 kids per family, at some way, shape, or form, in 2040, we're going to hit 9 billion, and sometime around 2100, at least at that point, we will max out at about 10 billion people in the world. So what's that mean for us? And why does it concern me as a genetics professor? And the answer is really, what are the challenges that are presented to us by population growth? Undernutrition, obviously, we'll talk about that a little bit next time. Disease transmission, boy, we are in the middle of it, and I'm going to use as many COVID-19 examples as I can as we begin talking about some of the different genetic techniques available to us. But certainly, disease transmission has changed radically with our increase in population. 1918, Still, we lost several million people, but there were many, many fewer people on Earth. Now we have many more people. We are closer together. We have air travel, lots of ways for infections to spread around the world. Not only lots of ways to spread disease, but a tremendous amount of social friction. We're seeing that even now because we experience more cultures than ever before in our human history. We have tons of misunderstandings, linguistic, understanding each other's languages, as well as cultural differences that we've got to learn to respond to. And this doesn't even begin to approach the ideas of human biology itself. Are we losing genes? Do we have a shrinking gene pool? That is, are fewer and fewer people contributing their genes to subsequent generations? Is there any natural selection at all? Or has cultural selection completely replaced natural selection? So these are some of the ideas and concepts that we'll be addressing throughout the semester using both traditional but also modern genetic techniques and ideas. And so I'm going to stop there. I'm going to try to keep these mini lectures at about 20 minutes. Please remember to read up on the introductory chapters. We'll talk a little bit more about those ideas in the next little mini lecture. You guys take care. Glad you're here and looking forward to meeting you in person. Take care. Stay safe.